Hello everyone, welcome to my YouTube video. My name is Krishna Kantopadhyay. Today we will discuss about 2D transformation in computer graphics. So, what is transformation? Changing an object's position, size, or orientation in shape within the XY plane. So, transformation means when we change in the position of an object, in the size of an object, or in the orientation of an object is called the transformation. So, there are basically three main types of transformation. First translation, rotation, and then scaling. So in translation, we change the position of an object from point P1 to point P2. In rotation, we change the we change the object by taking any pivot point in clockwise or anti-clockwise direction. And in scaling, we change the size of the object. So what is translation? So it is a repositioning of an object along a straight line path from one to another. Translation is a rigid body transformation. Translation that moves an object without deformation. Translation means when we change an object from one position to the other position without changing in its shape or size is called translation. So here is the diagram. We are changing the object from point P to the new point at P dash. The old coordinates are xy and new coordinates are x dash y dash. So the distance in x direction between this point is tx and in y direction is called ty. So here is the formula for obtaining new coordinates. X dash is equals to x plus tx, y dash is equals to y plus ty. So here is the matrix representation of this formula. X dash y dash is equals to identity matrix of 2 into 2 into xy plus tx dy. So this is the translation, and second is rotation. So rotation means repositioning points along a circular path around a pivot point. So means in rotation we rotate any objects by taking some pivot point. Like in this example, here is the original object and we are rotating this object clockwise in clockwise direction by taking this point as a pivot point. Here is the formula for obtaining new coordinates are x dash is equals to x cos theta minus y sin theta and y dash is equals to x sin theta plus y cos theta. So using this formula we can obtain new coordinates after performing rotation. So here is the matrix representation of this formula. X dash y dash is equals to cos theta minus sin theta cos theta into x y plus tx dy. So tx and ty will be given in question. A scaling transformation. Third is scaling transformation. So a scaling transformation alters the size of an object. Scaling of an polygon requires multiplying the coordinates value of each vertex by the scaling factor to get the new coordinate value. So meaning of the definition is scaling transformation change the size of an object. When you perform scaling means there is a change in size of an object. So the scaling of a polygon requires multiplying the coordinates value of each vertex by the scaling factor to get the new coordinate. When we perform scaling on a polygon, then to obtain the new coordinate, we simply multiply the old coordinate with the scaling factors in x direction or y direction. So here is the formula: x dash y dash is equals to x dot scaling factor in x direction, y dash is equals to y dot scaling factor in y direction. Dot means multiplication. If the scaling factors are greater than 0 and less than 1, then the size will decrease. And if the scaling factors are greater than 1, then the size will increase. If scaling factor is equals to scaling factor of x direction is equals to scaling factor of y direction, that means there is no change in shape. It means uniform scaling. So in matrix form, it can be represented as x dash y dash is equals to sx0 0 sy into xy x and y. Sx and Sy are the scaling factors in Sx means scaling factor in x direction and Sy means scaling factor in y direction. Now moving to next point, composite transformation. So composite transformation is a sequence of transformation, example rotation and translation combined into a single operation. Means when we perform two or more than two transformation at a single time in a single operation is called composite transformation. This is achieved by matrix multiplication, which is highly efficient. This can be this can be done by using matrix multiplication. M final is equals to m3 dot m2 dot m1 means, so these are the transformation that can be any transformation like rotation, scaling and anything. So the order of multiplication matters. So in composite transformation, the order always matters. Means rotation into translation is not the same as translation into rotation. So this is called composite transformation. Thank you for watching this video.